Hello students, let us complete chapter 1 and all that is left is some modeling problems. We need a bit of theory before starting it. Let's talk about some system of linear equations. And here's a motivational example. We have two equations and two unknowns. And typically I want ax plus by equals to something. And then cx plus dy equals to something. In general, I'm looking for this kind of form. Ax plus by equals to, I don't know, something like capital A. And then cx plus dy equal to something like capital B, and I missed a character. Okay, all right. This is a kind of structure I want. Capital A, capital B can be any number, in this case 6 and -1, and these coefficients can be anything, and of course they don't have to be integers. Integers are there just to make the problem simpler. Now how do we handle these? Typically what we want is solve for one variable from one equation and plug it into the other. Which one is simpler? I can solve for x or y from here, from the first equation, but looks to me solving for x from the second equation is easier, so let's go ahead and do that. Here, solve for x because x has coefficient 1, so I don't have to do any division. That's basically what this is. Flip 4y to the other side, and then x is 4y minus 1. Are you with me here? Excuse me. I needed some initialization, excuse me. Okay. Oh, come on. Okay. So from here, solve like this, and please pay attention to this red part. Here, I'm plugging in. And if I do that, you see, the red part replaces the x part of the first equation, and what do we have? We have an equation of y, just one variable, and then solving this is just standard. What is the standard process? Denominators, parentheses, and like terms. No denominators, but we do have parentheses, so let's go ahead. Break up the parentheses, right? And then take the like terms together. Breaking up the parentheses, all right, and then take the like terms together, and then you can solve for y. Divide by -5, and then we have the answer. Actually, one of the two answers. -8/5. Halfway through? Actually, more than halfway through. Half of the answer is done, but as a matter of fact, most of the hard work is already done. Now all you have to do is plug in this number, y equals to -8/5, into any one of those equations and solve for x. And which one is the best? You can put it here if you want to. You can put the second equation there. But I generally like to do it here. X equals to something is already there. So put it into the right equation. So -8/5 goes in place of y. And then do some computation. Here I just use all those symbolic computations, but you can use your calculator. And then you can convert the decimal back into fraction. If you're using those TI-80 series calculator, just go to math mode, and then the default is changing decimal to fraction. So math enter to select the default, and then enter again. So math enter, and that's going to give you the simplified fraction. If you can handle all this symbolic computation of all those fraction computation, that's fine. If you can't, or if you want to cut down mistakes, you can use calculator like that. In any case, we found out y value earlier, and then we just found out x value, put those together, and then we have the solution. This kind of method is called the substitution method. Most typically, you're going to be expected to do this. Let's go back again. Ax plus by equals something, and then cx plus dy equals something form. Just select any one equation that is easy to solve. In this particular case, Second equation is, second equation, especially the x is easiest to solve. So that's what I'm going to work on. So flip this 4y to the other side. From here, 4y to the other side, and then that's what we get. X equal to negative 4y minus 1, which I just highlighted in red. And then plug that into not the same equation. If you do that, you're going to get negative 1 equal to negative 1 or 0 equal to 0 or something like that. It's not going to give you anything. Put it into the other equation right here and then do some further algebra. It's not going to be difficult. You'll have to break some parentheses. That's about it. And then go ahead and solve for y. Got one of the two answers. And then plug it into any one of the equation. This is probably the best. And then run your calculator. You get the answer. Now there are other kind of solution method. Elimination method. Some people like it. Yeah, I do. But my experience was a little bit negative for students, so I'm not going to talk about it. And the substitution for nonlinear equations, nonlinear systems of equations, is something we're going to be covering way back. Excuse me, I take it back. We're going to cover those systems of nonlinear equations just before the final exam, yes, in week 15. But it'll show up here and there as intermediate steps of some other problems as well. So we don't really need it yet, but we'll have to come back and discuss it from time to time. So let's not just completely throw it away. Still, our focus of attention is this one. The system of linear equations using the substitution method. Okay? Ready? Let's go to some modeling problems. And here we go. Can everybody read it? Let me increase the font. Example 2.1. By the way, I just copied this problem from the textbook problem. So if you just read the textbook problem, you'll find the same problem there. Okay. Candy has $70,000 to invest and wants the annual income return of $2,800. She can invest in a safe government insured certificate of deposit that pays 2% of annual interest and a riskier corporate bond that pays 7% of annual interest. How much should be placed in the investment to achieve the goal? How much should be placed in each investment vehicle, I think? No. It reads exactly the same way in our textbook. Okay, all right. So how do you set up? Well, let me open up the system of linear equation. This is a basic structure you're headed. And in particular, I am particularly interested in this kind of form. Oops. This kind of form. Let's not pay too much attention to all those. Let's not pay too much attention to all those characters just yet. Something. And then most typically, this is the structure I want. Down here in general, we have some cx plus dy, but I am particularly interested in the case where I have just x plus y. Yes, I can consider harder problems where this is another, come on. Okay, this part is another cx plus dy form. I can consider harder problems, but these kind of modeling problems are difficult as they are, so there's no reason for me to twist it further and make it worse. So this is typically the way to go. Alright, how do you set it up? Hint, I already gave you a hint. X plus y equals something will show up there. Any keyword? Total, sum, that's going to be corresponding to x plus y. Okay, here we go. Here's the solution. Here's the setup. Let's say x is CD and y is corporate bond. You can choose different characters or change the order, it doesn't really matter. But the key is this. X plus Y is total $70,000 to invest. All right? And then how about the other? The interest. 2,800. That's going to be another number. 2,800. And then those are related to 2% and 7% each. Make sense? We want X plus Y equals to something. And then AX plus BY equals to something. And equal to something part are rather clear. We have 70,000 and 2,800. 70,000 and 2,800. They are rather clear. Which is X plus Y and which is AX plus BY. You need some experience, but here we go. Once you have your setup, solving this is not too bad. Solve for either X or Y and plug it into the other equation. Here I decide to solve for Y. Okay. So Y is 70,000 minus X. So plug that in place of Y right here. And that's going to give me 70,000 minus X in place of Y from the second equation. Next, just a standard process. Number 1, denominator. Number 2, parentheses. Number 3, like terms. No denominator, so let's go ahead with parentheses. Break up the parentheses. That'll give me this part. And then take the like terms together. 0.02x minus 0.07x. Negative 0.05x. And then how about those number part? 2,800 was there before. Flip over to 4,900. So subtract that. And what do we have? 0.05x. Negative 0.05x is equal to negative 2,100. With the help of calculator, you can easily divide and you're going to get 42,000. That's the amount that goes to CD. Alright, how about corporate bond? Total should be 70,000 and 42,000 we found out. So we're getting 28,000. 70,000 minus 42,000, or from this equation, you're going to get that. Solution, not too difficult. Setup, that can be a little bit difficult at times. And remember the structure. X plus Y equals to some number. Most typically, it's going to be given. Look carefully. And AX plus BY equals to some other number. And what are those rates? AX plus BY. Again, look carefully. Now, another tip. How do I get those A and B, those coefficients? And those can be answered very often from the units. Let's see. 2% of annual interest rate. The problem did not really specify rates, so I take it back. Looks like unit problem is going to be something that I'll have to discuss in the next example. Okay, thank you. Let's stop here and we'll move on to the next example in the next video.